Welcome back to Anatomy and Physiology here at AWC, Arizona Western College. I'm your professor, Dr. Sean Clavel. Today we're going to be talking about the chemical composition of bone. Now, bone consists of inorganic and organic compounds here. It's the organic compounds that include the cells, the osteogenic cells, osteoblasts, and osteocytes, as well as osteoclasts here that make up about 2% of the bone's weight. It's the osteoid. Osteoid is the organic material, which makes up about 33% of the weight of the bone, which is really the collagen fibers. Collagen fibers are strong and flexible. Think of them like a rope, but if they're compressed, they bend. So the organic compounds of the bone give it its flexibility, whereas the inorganic compound is hydroxyapatite. These are mineral salts that account for almost 2/3 of the weight of the bone. Calcium phosphate interacts with calcium hydroxide to form crystals of hydroxyapatite. As they form, these crystals incorporate to other salts such as calcium carbonate and ions such as sodium, magnesium, and fluoride. By combining the hydroxyapatite with the collagen fibers, a strong, somewhat flexible material is produced. Right? The organic compounds, the collagen fibers, give it its flexibility, whereas the inorganic compound, the hydroxyapatite mineral salts, give it its rigidity. By combining this hydroxyapatite with the collagen fibers, we get this protein crystal combination that's highly resistant to shattering, as well as providing strength and lightness, right? Giving it a good amount of lightness. In fact, bone is far superior to concrete. It may be more on par with steel reinforced concrete. Bone is associated with 4 cells that account for approximately 2% of all of the bone's weight. This includes osteogenic cells, osteoblasts, osteocytes, and osteoclasts. We'll look at each of these individually. Starting with osteogenic cells, these are mesenchymal cells. So remember, mesenchymal cells are adult stem cells of the connective tissue variety. They're located within the periosteum as well as the endosteum. These stem cells divide to produce daughter cells that differentiate or specialize into osteoblasts. They're also important in the formation of osteocytes. So next we'll look at these osteoblasts. Osteoblasts are immature bone cells located on the surface of the bone. They produce new bone matrix in the process called osteogenesis or ossification. Osteoblasts make and release the protein and other organic components of the matrix. Before calcium salts are deposited, the organic matrix is called osteoid. Osteocytes develop from osteoblasts that have become completely surrounded by bone matrix and trapped within a lacuna. Osteocytes are mature bone cells that maintain the protein and mineral content of the surrounding matrix through the turnover of the matrix components. So what these osteocytes will do is they'll secrete chemicals that dissolve the matrix, break down those calcium salts, and release them into the bloodstream, into circulation. These osteocytes can also rebuild the matrix, stimulating the deposition of mineral crystals. So they really maintain homeostasis rather than complete a number of anabolic or catabolic. It's more of a maintain homeostatic balance. They can also participate in the repair of damaged bones as well. And then we have osteoclasts. Osteoclasts are bone digesting cells that remove and recycle bone matrix. These are giant cells, as you can see here, with more than 50 nuclei. Osteoclasts are not related to osteoprogenitor or osteogenic cells. Instead, they derive from the stem cells that produce phagocytic white blood cells, called monocytes. Acids and proteolytic enzymes secreted by osteoclasts dissolve the matrix and release stored minerals. This process is called osteolysis or resorption. It's important in bone remodeling. And that brings us to the 4 types of cells found in the bone. Osteogenic cells, also known as osteoprogenitor cells, they're responsible for developing into osteoblasts. We have osteoblasts, which form the bone matrix. Osteocytes, which maintain bone tissue. And the osteoclasts, which are a derivative of white blood cells, monocytes, that function in the resorption or the breakdown of bone contents. Remember that bone contains inorganic and organic compounds. Those inorganic compounds are called hydroxyapatites. They primarily the calcium phosphate salts that make up the bone and are comprised of 2/3 or 66% of that bone. The other third of the bone is organic compounds, not only the cells, but this content's called osteoid, which contains quite a bit of collagen fibers, the protein fibers that give it its flexibility and a little bit of toughness as well. And so that'll wrap up the section for the chemical composition of bone. Stay tuned as we look at the microscopic anatomy of compact bone, as well as the bone formation and development. Take care, and I look forward to seeing you then.